Hello and welcome to Guessing the Specialist exam. Now last year I collected a bunch of questions from all around Australia. This year we're doing something different. These are my past students. You know they're good because I taught them. They've written a specialist exam for us. They also started this company here. Check out the website, link in the description. They do all this cool stuff. First question. So pause the video, have a try, see how you go, and then I'm going to do it. Now if you're not walking around with your formula sheet, what are you doing? Because we've got some formulas up here. So it says determine the sample mean and sample standard deviation. So the sample mean, very, very straightforward. The sample mean, which we've denoted here with this little symbol, is always equal to the population mean. So it can be assumed that the European, the mean of 160. Okay, so simple, the population's 160, the sample mean is 160. Now, the standard deviation is going to be equal to the population standard deviation. So determine the sample mean. Population standard deviation is 2 over the square root of the sample size, 25. All right, square root of 25 is 5, so we get 2 over 5. I think I can see my answer here. It is C, celebration. And next question. All right, pause the video, maybe get your formula sheet out, have a try, and I'm going to do it. Now again, formula sheet, very useful. This is simple harmonic motion. A particle oscillates in a straight line. Its acceleration can be mapped using the function acceleration equals negative 16x. Okay, well that's interesting information because that's what this is here. Acceleration is equal to negative omega squared x. All right, I'm going to write that down before I do anything else. So that means that I actually can figure out now what the value of omega is, I think. Because this 16 here is omega squared. So 16 equals omega squared. Now I was going to go further than that, but on second thought, I'm very interested in omega squared. I'm not that interested in omega, so let's stay there. All right, with that information, knowing that omega squared is 16, I can now come up with something, or I can at least start working on a velocity function. So I can say that v squared equals omega squared, which is 16, and then this capital A squared minus x squared. Now that A right there, that is the same as that A there, which is the amplitude of our motion, which is the thing that we want to know. Determine the amplitude of the motion. So we really want to know what that is. Now, luckily we are given some information. We are told that the velocity when x is equal to 0 is 2. So let's put that information in. 2 squared equals 16, a squared minus, and then 0 squared. All right, so 4 divided by 16 is 1/4 a squared, right? And that means that a is equal to the square root of 1/4, which is 1/2. All right, I think we've got our answer there. It is B, celebrate, done. Next question. Okay, so this one here really just feels like a test of memory more than anything else. We're looking at an exponential probability distribution function, a mean wait time of 6 minutes. So we're just putting it into our formula. You should do this. The answer is C. I don't think I've got any working to do here. If you think I needed to do more than that, let me know, but it's 1 over the wait time, 6, e to the negative 1 over the wait time. That's a formula that you should just have sitting in your head, ready to go. Easy marks, celebration, next question. Now the really nice thing about having my past students write these papers is that they do things that I wouldn't do. So question 1 here, projectile motion, that is tricky, but the question is simple, familiar, definitely. I'm backing this 100%. Have a try, see how you go. All right, I'm going to do it. A child standing on a platform. A very good idea when you've got projectile motion is to draw a picture. So let's do that. We've got a platform and the child is standing on the platform and they're throwing a thing. And it's a platform, so the ground must be like lower. All right, so it's a very good idea to get a sense of what you're doing before you start, so you understand what's happening. All right, part A. Determine the maximum height above the ground. Okay, above the ground. So determine that maximum height where the vertical displacement is, assuming the ground is where the vertical displacement is equal to 0. Okay, so we're assuming that this is where like height 0 is. Because you could assume that this is where height 0 is. But they're saying, no, the ground is where height 0 is. Okay, how do we do that? How do we do that? How do we do that? All right, at this point, it's important to understand the motion of our projectile, right? On this, its velocity is going this way, and it's also going up. It's going this way and this way with some amount of speed. Over here, it's going this way and downwards with some amount of speed. But here, it's not going up and it's not going down. Hope we don't run out of power. It's doing neither of those things, right? In other words, its vertical velocity is equal to 0 at its maximum height. All right, so at max height, vertical velocity is equal to 0. Now, I haven't been given a velocity function, I've been given a displacement function. But that's fine, because I can find the velocity function by deriving the displacement function, which looks like it's going to be easy. The derivative of 2ti is just 2I. And the derivative of this next part, we've got, let's make sure that we got this right. T, negative t plus 1, and then a plus 2. All right, and that's j. Now, that's the vertical velocity. That's the thing we want. So I need to derive that. I haven't derived it yet, so this is a bit annoying. It's negative t squared plus t plus 2. I still haven't derived it, so technically that's not true. I'm going to have to delete this and start again. Minus 2t plus 1. Okay, that is the velocity of it. So I'm going to get rid of those. And put that negative 2t plus 1. That is my j component. All right. So the question is, when is that equal to 0? Because that will give me my max height, because that will be when my vertical velocity is equal to 0. 0 equals negative 2t plus 1. Negative 1 equals negative 2t. T equals 1/2. At time 1/2 the maximum height. All right, it says determine the maximum height. Well, that's a little bit annoying because now we need to sub this t into our original equation, but into this portion of our original equation, right? Because we don't care how far across it's gone, we just care what the height is at that time. So sub in to the j component of that with respect to t, but only the j part. We don't care about the rest. It's going to be equal to 1/2 bracket negative 1/2 plus 1 plus 2 j. All right, so negative 1/2 plus 1, that's a half. A half plus a half. A half times a half is a quarter. But it's going to be, a positive a quarter plus 2, 2 1/4. 2.25 meters high. Okay, does that make sense? I guess it could make sense. We don't know how high this pit was, but, you know, obviously they're not super high in the sky, so 2.25 meters, that's the maximum height of our projectile. All right, we're going to do part B now. I've just drawn my person down here, give me some more space to work. It says, determine the total range of the projectile. Now, Now, this is something that people always have trouble with, like, what am I supposed to do here? I don't really get what's going on. Well, the range of the projectile is how far it travels from here to here. The horizontal displacement from here to here. All right. Now, how do we figure that out? We don't have to calculate how far we are here, how far we are here. We just need to know the horizontal displacement when it hits the ground. How do we find out when it hits the ground? Well, it hits the ground when its vertical displacement, its j component, is equal to 0, right? So we just need to solve when is the j component equal to 0. So the j component can be written as negative t squared plus t plus 2, and we need to know when is that equal to 0. It's going to be easier for me to write this as t squared minus t minus 2 equals 0. I think maybe that factorizes neatly, I hope. Let's go with like a minus 2 and a plus 1. That'll work. Okay, so there are, what does that mean? Equals 0. What does that mean? There are 2 times when this projectile touches the ground. It touches the ground when t equals 2 or when t equals negative 1. Okay. What is the t equals negative 1? What is that? That's this point over here from like before when the kid, like imagine the kid didn't throw it from there, but the kid was actually lower down. That's where it would be, right? So we reject the negative at time 2. At t equals 2, hits the ground, hits ground. Done. All right, now that we know that at t2 it hits the ground, we just need to know how far across it was when that happened. How far across from its initial position was it when that happened? And that is that value right there. So 2 times 2 equals 4. Determine the total range of the projectile, 4 meters. Now, I did sort of think about this a little bit because after I've done this, I'm saying, okay, the range of this projectile is 4 meters. Some people might come at me in the comments and be like, range means the total number of y values, right? Range has two meanings, a colloquial meaning and a mathematical meaning. I think because we're talking about projectiles and the range of a projectile, this is what's meant. I don't think we're talking about the total number of x values it can take, because that doesn't even make sense in this context. We're not even looking at x values, we're looking at I and j components. So I'm going to stand by my answer of 4 meters being the total range from start to finish from where that projectile landed. On to part C. So part C is asking for an overall change in height. So that's this right here. I think I've got a bit of a whoopsie there, so we don't need that. So it's this height here that we're looking for, right? So I need to know, okay, that's where it hits the ground. So at there it's height 0. What's its initial height? That's really the question that's being asked. And its height is given by this part of our equation here. And at time 0, we want to know what's the height. So it's simply just subbing 0 in for t into that portion of our equation. Okay. So that's just 0 times 1, which is 0 plus 2. And that's our j component. So at the beginning of its thing, it's 2 meters high. Now, that's where like the person throws it from. And then when it lands at 0. So determine the overall change in the projectile's height from an initial height to the landing position, 2 meters. That's what I understand by that question, the net difference between where it started and where it finished. All right, I think we can celebrate. And I think we've got one more. All right, so I think we've got some pretty tricky sort of calculus here. The integral of sec to the power of 4x. Let's start with that one. It looks like some kind of u substitution. It's a good idea to take a look at your formula sheets because this is some sort of trig identity type thing. So I've taken a look, and I've got this one here, which I think is going to be useful. So I'm going to go the integral of sec squared x, right? Because that's just sec 4x. Now, why am I writing it like this? Because I can replace that second sec squared x with tan squared x plus 1. And you might look at this and just sort of think to yourself, why? Like, what would possess a person to make this decision to do this? And the reason is because I'm looking for a way to do u substitution. And I need two elements to do u substitution. One, which is the derivative of the other one. And I have that here. I have the derivative of tan x is equal to sec squared x. So I can let tan x equal u here. So let's see what happens when I let tan x equal u. All right, so let tan x equal u. That means that the derivative of u with respect to x is equal to sec squared x. The derivative of tan x is equal to sec squared x. All right, and that means that du sec squared x is equal to dx. All right, so this is all important stuff. Usually I do this sort of off to the side a little bit. Okay, now that I've done that, I can sub in some stuff into my equation. I can say the integral of sec squared x times, now u is tan x, times u squared plus 1, not dx, but du sec squared x. And now it's obvious why I've done this, right? Because now I've got this sec squared x and this sec squared x that cancel each other out. And what I'm left with is the integral, let's do it up here, the integral of u squared plus 1 with respect to u. That's simple. We've got u cubed 1/3 or u cubed over 3, whatever you want to do, plus u plus c. Okay, so that now u isn't u is tan x. So 1/3 tan cubed x plus tan x plus c. And I'm done. So a very clever kind of trig identities integration style question. You really want to understand the mechanics of u substitution. You really want to understand what you're doing, how you're selecting your u. You want your u to be such that when you derive your u, what you've got is the thing that's kind of in your way, right? I hope that makes sense. Okay, that's part A. We've got a part B here, which annoyingly, I always do this, is missing its little dx here. So there should be a little dx on the end. Let's celebrate this one, and let's do the next one. Okay, so it should be super clear to you that this is a partial fractions style question. So let's start on it here. That's going to be equal to the integral of 4x plus 10 over x squared plus 5x plus 4. That definitely seems like it must be like x plus 4, x plus 1. Okay, with respect to x. Now we need to have this as a partial fraction, and so it should be clear to us, and we'll do some work here, that 4x plus 10 over x plus 4, x plus 1 is equal to a over x plus 4 plus b over x plus 1, right? So we should be able to do that as partial fractions. That's something we should be very, very familiar with. We can rewrite that as a x plus 1, so we're multiplying this by x plus 1, plus b x plus 4, all over x plus 4, x plus 1. Okay, that's good, because now we can ignore those denominators and just say, therefore, 4x plus 10 equals a x plus 1 plus b x plus 4. Neat. Okay, the key here is to sub in values for x that are convenient. Sub in values for x that will make the a go away, and sub in a value for x that will make the b go away. So if I sub x equal -1 in here, right, that will be -1 plus 1, so the a will disappear. So I'll be left with 4x plus 10 equals gone, and then b times 3. Hopefully that makes sense. -1 plus 4, 3, 3b. Okay, and we need to sub our x in there as well. -4. All right, so -4 plus 10 is 6 equals 3b. So b is a nice, neat little number. B is 2. Okay, so we can sort of make a little note of that here. So we know b is equal to 2. I might just get rid of that. Don't have a lot of space. And I'll sub the other convenient value, which is -4. Because that'll make that b disappear. So we end up with 4 times -4 plus 10 equals a -4 plus 1. Okay, 4 times -4 is -16 plus 10 is -6. And then we have this a, -4 plus 1 is -3. So that's -3a. So a is equal to -6 divided by -3. 2. A is 2 as well. Okay, so finally we've got what we need, because we can now say that this integral, we can rewrite this as the integral of a, which is 2 over x plus 4, plus b, which is 2 over x plus 1, all with respect to x. And we can easily integrate that, and we can easily integrate that. We have 2 ln absolute value x plus 4 plus 2 ln absolute value x plus 1. And of course, don't be like me, remember your little plus c on the end. Now, are there other ways to put this together? Yeah, there's a common factor here of 2, so you can sort of bring a 2 out the front. That ln x plus 4, ln x plus 1, you can use log laws to smush them together. I'm pretty happy here. We're going to stay there. Beautiful. Done. Celebrate. Question. Done. All right, that's 5 questions down of guessing the specialist exam. It's been a super pleasure to do, mostly because I didn't write the questions, so we're getting something different to what I would normally think about. So thanks to these past students. Definitely go and check out the website. They do cool stuff. The free newsletter that you can sign up for, they do all sorts of subjects, not just maths. So recommend. Check it out. Peace out. See you for the next one.